Welcome, linear algebra exam review. I will try to keep this less than 25 minutes because I promised you at the beginning of the semester that I will not keep any week more than 2.5 hours. So let's go. Introduction to linear algebra, like there was one lesson in this module. So linear algebra, like we have a system of linear equation, for example, and we can express this in a convenient way, like in a matrix form. So I have here my right hand side, and I have here this like coefficients. Like so, the coefficient here is for x1 is 4, for x2 is like -5. Yeah. For x1 here is -2, for x2 here is 3, and this is my right hand side. So I can express it. So I can express like 4 and uh, and -5, and then -2 and 3, my right hand side -13, and then my variables here like x1 and x2. So I can express it in this form. This is called like matrices form. So here I have like matrix A, matrix X, and matrix B. And then once I express it in the matrices form, then I can do matrices operation. Like I can add two matrices, I can subtract two matrices, I can do like multiply two matrices, I can do like matrix inverse. That would be like equivalent to division. That's called like a matrix inverse. So here in the exam, like you will get something like this because that's something very basic. So like I tell you, like matrix A and matrix B, like you can add these two together. So I tell you, so that's matrix C. Like D is equal to A times B. So like I have matrix A and matrix B. So this is like 2 by 2, and this is like 2 by 2. And if I want to know whether I can multiply these two matrices or not, so here, and then there, like if this 2, like this 2 is equal, like this number is equal to this is equal to this, then I can multiply and the resulting matrix will have the dimension of 2 times 2. Yeah. So 2 here means like 2 rows times 2 column. Yeah. Similarly. Yeah. And how to do this basically. So like to do this, like you multiply like this guy by this guy, and that would be like this guy here, and then you multiply like this guy by this guy, that would be like this guy here, and then you multiply this guy by this guy, that would be this guy here, and then multiply this guy by this guy, that would be this guy here, and then that would be the resulting. Is a matrix inverse. You can use this formula, for example, if it's like a 2 by 2 matrix, and so that's the determinant of the matrix, and that's like how you do it. So if I want to say like the inverse of matrix A, you just follow this formula, then you'll get something that looks like this. Yeah. Okay. So I can like I think there's system, like I have like a system of linear equation, like I want to solve for like x1 and x2. Yeah. So if I want to solve for like x1 and x2, I could either represent it like in the matrix form. So that's like matrix A. So I have like this coefficient here, I have this coefficient here, and this one like my variable, and this is my right hand side, and then I can basically uh, solve for x. Yeah. So I can solve for x here. So that would be like, so x here, that would be like the inverse A inverse time B. Yeah, that will give me. That's how I can solve for x. Yeah, like A inverse time B. Yeah, or I can just express it like I can express x2 as a function of x1, x2 as a function of x1, and then if I equated these two, then I solve for x1, then I substituted any of this equation, and then I solve for x2. So a system of linear equation, yeah, will have a unique solution, a single point where all the equation intersect. Yeah, so the solution have like this, like two, like the red one and the blue one. At this point where they intersect, that would be like the unique solution. It has no solution, like see when they are parallel, like for example to one another. So this system of equation, it has no solution, no intersection exists because the equation are uh, contradictory. Yeah, or like here in that case they're parallel to one another, or infinite many solution, continuous set of points, e.g. a line or a plane where all equation are satisfied. So you see here like that's the same line basically. So there are infinite like a solution everywhere. Yeah. So that's basically the three cases, like unique solution, no solution, or infinitely many solution. So how can we solve like a system of linear equation where we find like where these two lines intersect? So in that case, the unique like that system has a unique solution which is like 3 and 5. For x1 is equal to 3, that's equal to 5. That's the solution. So we can solve it graphically. Graphically is like we plot the two lines and we see where these two lines intersect. Yeah. So that's like one way of doing this. Yeah. Uh, so I plot like the first line x2 as a function of x1. So I have an equation for x2 and I substitute like different x1 values and I plot this blue line. I have an equation for x2 and I substitute different xy value and then I plot this red line and I see where these intersect. Algebraic solution. So algebraic solution basically like you can just like use some algebra here. So I can say like x1 is equal to this. Then I substitute like x1 either in this equation or that equation. Then I solve for like x2. Then once I have x2, I can substitute it in this equation or that equation, and then I solve for x1. Yeah. But usually, because it's easier to just like use and like here you can do this because you have only two equations. But like, what if you have 100 equations or 200 equations? So obviously that would be tedious, and that would be tedious. Yeah, and that's why it is convenient to express this like in the matrix form, because if you have uh, uh, many equations, so like I can express this in a matrix form, then I have uh, AXB, then I like I multiply by the inverse of A, because like these two can go together. This one, the inverse of the matrix times the matrix itself, like they give you an identity matrix. So here that's like an identity matrix, that's one. So I get rid of this guy, and then I end up with this equation. So basically, if I got the inverse of matrix A multiplied by matrix B, then I can solve for x here. Yeah. So here's just like my matrix A, that's the inverse of the matrix A. So I can calculate the inverse of the matrix A. So I have like the inverse of the matrix A, I multiply by B, then I got something. Can we multiply this? We can check. So how many, this is like 2 by 2, like 2 row and 2 here. And how about this guy? This guy is like 2 times 1, because I have 2 rows and 1 column. So this is like 2 by 2, so this means I can multiply this to the resulting one would be 2 by 1, which is exactly what I got here. And how to do this? Multiplication, basically, like, so you multiply uh, this guy by this guy, and that will be like this one here. And then you multiply this guy by this guy, and that would be like this one here, or like this one here. Yeah, that's here. Okay. So that's basically like, so these are should be like easy trivial problems in the exam, like you should be able to do well in this, yeah. Now, but sometimes we also like, that's what we generally do is like numerical solution, because like you have no like analytical like because this one, like you can use this like laws of algebra, but in the computer will solve it numerically. The computer can also use this laws of algebra, but in the computer, like the computer will solve it numerically. And then one way is like Gauss elimination, like forward elimination, and by so the computer can do also symbolic calculation, but usually we use we'd be using like numeric solution. So what we do, like we can express this is called the augmented matrix. So the augmented matrix, like you have your coefficient here, and here like you have the right hand side. And one, there are so many numerical solution method. One is called like the Gauss elimination. So Gauss elimination, that's like forward elimination and back substitution. So basically, like the idea here, I have like this coefficients, and what I want to do, I want to create like a triangular matrix here, like of 0 here. Because why? Because if I have this guy and I have this guy, this is just one equation and one unknown. So if I have like this guy and this guy, then I could solve for like x3. Then now if I have x3, and now here I have two equations for two unknown, I have x3, then I can substitute this here, then I will get like x2, and then here I will like get x1. That's basically why we want like, because here like one unknown which we can solve for, like two unknown which we already have one from here, then we can solve for, and then like three unknown we have one from here and one from here, we can solve for this one. So that is something you should be able also to like, you can just like, so here's, this is a practice problem, so use like naive Gauss elimination. So please like go to the main lesson, make sure that you can solve this, yeah. So make sure that you can do like this numerical solution. Again, this is another form of numerical solution which we are learning in this course. So basically you convert this matrix to an augmented matrix. Forward elimination, multiply row 1 by 4 over 2 and subtract the result from row 2. So it's just numerical solutions. They are not difficult, they are easy, but they are tedious. It's just recipes that you have to follow. So you just follow the recipe and you will get there. Yeah, and make sure not to. The difficult part would be that you do like some arithmetic mistakes. Yeah, like when you multiply like this one by like 4 by 2 and then you subtract it from this one, you can easily do some arithmetic mistakes. So make sure you don't do arithmetic mistakes. But if you did this, then you will end up with this triangular matrix. Like here you have like 0 and here you have like non-zero, and then you can do back substitution. So like I know like this is my x1 here and this is my x2 here, so I can use this equation to solve for x2. I got like this guy, and then like I can put x2, I can substitute x2 here, then I can solve for like x1. Yeah. So again, like in the exam, you should have something like this. You should be able to do these types of problems. They are easy but tedious, and you don't make sure not to make arithmetic mistakes. So I think that's all. I kept my promise of making this less than 2.5 hours, and good luck in your exam. And if you have any question, make sure to stop like during office hour and make sure to get in touch with me and I can help you. Okay. And if you want me to print like the tables for differentiation and equation, you don't have a printer, just let me know and I will print it for you. Okay. Okay. So good luck in your exam. Bye bye.